Okay, let's begin our today's physics class. I cannot go on waiting for your friends to join. Today we are going to derive mirror formula, and at the same time as we learn the mirror formula, we are going to learn how image a form and how a Cartesian sign used and terms, all the terms related to mirror. So we're going to learn four things in one go. So mirror formula, the formula is 1 by V plus 1 by U equal to 1 by F. This is mirror formula. I think it's not visible there. Let me write it again. So mirror formula 1 by V plus 1 by U equal to 1 by F. We are going to derive this formula. And I'm going to make it very short and very simple. So let's start with the diagram. I have already asked you to draw some diagrams. So as for that diagram and the description, we'll come to that after we do this derivation, because that will become much more clearer if you understand what we're going to do today. So let's start with a very simple diagram. We'll take a concave mirror. This is a concave mirror, right? So concave mirror is nothing but a mirror where the outer side is a reflecting, the inner side is a reflecting surface and the outer side is silvered so that it reflects. So now we're going to talk about some of the terms. So here I've written terms relating to mirror. So if you can see what's on the screen, so this point is called the pole, right? This point is called the pole, and since spherical mirrors or concave mirror for this case, concave mirror is cut out of a sphere, it should have a center of curvature. So it should have a center. So let's assume that this is the center. So the center of curvature. Center of curvature. So center of curvature is the point. Let's say if you assume that this is a whole sphere, then it should have a center. So that center in mirror, we call it center of curvature. So right in the middle between the center of curvature and the pole, this is the pole, we have the focus. All right, we have the focus. So this is called focus. Now this focus always lies between the pole and the center of curvature. And whenever you are to draw any image of formation, the ray diagram should always pass through the focus. Now, since this is right in the middle, now this length between the focus and the pole is also called focal length. Focal length, it is represented by small letter f. The distance between the focus and the focus and the pole is called focal length. All right, and this line passing through, this imaginary line passing through the pole from the center of curvature, this line is called principal axis. Principal axis. All right, that's principal axis. I'm not going to wait for your friends. All right. Right now, there's only 8 of you, because this is going to require a lot of time. I cannot go on waiting for people. So I'm going to start, and in case in between the meeting ends and I don't finish, you just join in again, because it's going to take about 15 minutes. And I'm going to go very slow so that you understand. So this is the focus, this is the focal length, the distance between the focus and the pole. Now, about the Cartesian sign, we have finished some of the basic terms relating to mirror and image formation. About the Cartesian sign. Now, any measurement, all measurement should always start from the pole. So measurements are made always from the pole. It always starts from the pole. Then, if objects are always placed on the left-hand side of the mirror, the objects are always placed on the left-hand side of the mirror. So, and the ray comes this way, all right? This is the direction of the ray. Now, since the measurement starts from the pole, this measurement, if it is against the incoming ray, because let's say from here, like I mentioned, if this is the point O, then if the measurement is on this side, on the left-hand side, OC, for example, it should always bear negative. This is important. It should always be negative. So there should be a negative sign before the term. So OC equal to -5 centimeter, for example, right? So, but if the measurement is along the ray or behind the mirror, this is behind the mirror, this is in front of the mirror, this is in front of the mirror. This is behind. I don't know whether it's visible. I think it's not visible. So anything, any measurement which is behind the mirror should always be positive. I hope you understand. So all measurements starts from the pole, and the measurement which is made against the incoming ray or in front of the mirror are always negative, like this. OC equal to -5 centimeters. This is just an example. Then any measurement which is made along the ray or which is behind the mirror, right? Which is behind the mirror should always be positive. So image form behind the mirror, they're always virtual. So if the distance, the image distance, let's say V is plus 30 centimeter, in that case, the image is virtual. But if the image is formed at -25 centimeter, then this image is real. And it is formed in front, it is always formed in front of the mirror. So that's about the Cartesian sign. And one more thing about Cartesian sign is measurement which are above this principal axis. When you're measuring it vertical and it goes up, it should be positive. If it goes down, it should be negative. That's very similar to your what you call quadrant that you have. All right. So all the values on this side are plus. Here they're all plus. So on this side, here the x is minus, and y is plus, positive. So it's like you have that Cartesian sign in your coordinate geometry and graph, right? So very similar to that. So this is about the basic that you have to have in your mind as you go about finding deriving the formation, deriving the value of, deriving the formula of a mirror equation and image formation. So the diagram that you were drawing, will come to that in the next physics class. There we have to write the description, and many of you did not do the assignment, and some of you, didn't do it. So in order to derive this mirror equation, I'm going to take an object which is placed beyond the center of curvature, which is, okay, let me just take it a little further. An object which is placed beyond the center of curvature. So this is an object A, B. It stands like this. In optics, the portion that we are talking about now is also called optics. All right. So in optics, signs and the sign, the direction, the ray are very important. So from the top of the object, there will be a ray which falls on the mirror. This is a concave mirror. Remember, the mirror that we use now is concave mirror. Then it reflects. It comes back. Then from here, from the top, one comes through the center. It comes like this. Then the image is formed here. So when the object is placed between beyond the center of curvature, the image is formed between the center of curvature and the focus. If you turn your page and look at what you have written, the image that you have, the image formation that you did, you will have it like this. So this image is inverted. So I'm going to take an imaginary line perpendicular to AB, and I'll call this as M, I'll call this as N. So if possible, I'll try to upload this video on YouTube so that you can, watch it over and over to understand, because I will not have the time to explain it again and again. So if possible. So now I'm going to cut short many of the things that we need. I'll write only the important ones. So here AB represents the object, and the image is A dash, B dash. All right, so I'm going to make it very simple and try to keep it short and keep it short. So here, I'm not going to write the details of the image formation. I'm just going to bring in whatever we have in the figure. So here, the object distance. Let's identify the object distance. So OB. So OB, like I mentioned, all measurements starts from the pole. So in this case, the pole, we're supposing it to be O. So OB is the object distance. So OB equal to, okay, wait, let me write in words. So object distance equal to OB. I hope it is visible. So OB equal to object distance is usually represented by U. So U represents object distance. Is it visible? Let me just go rapidly. Object distance equal to OB equal to minus U. Now, why do I take minus U? Because here OB, it is in front of the mirror. The measurement is in front of the mirror. That is why it becomes minus. Then image distance equal to, so here image distance is OB dash. So OB dash equal to minus V. Again, the image is formed in front of the mirror, therefore the image distance becomes negative. Then focal length OF equal to minus F. So for concave mirror, the focal length should always be negative. But for convex mirror, the focal length is positive. Keep that in mind. For concave mirror, I repeat, for concave mirror, the focal length should always be negative. Then, what do we have? Yes, let's write the relation between the center of curvature, the radius of curvature and the focal length. So that's OC. I'll just write like this. OC, this is the radius of curvature. OC equal to minus 2F. So this OC, the radius of curvature, or you can represent it as R, capital R if you want, but I'll just put it OC here. So OC equal to minus 2F. So let's begin. Now, why did I teach you this? Teach you similarity before in the mathematics? That's because the similarity is used in physics.
I think there is a net problem. Students need to wait.
So similarity is used here in this derivation, and at the same time we use it in coordinate. So that is why you need to be very clear about the lesson similarity in your mathematics. So now triangle ABC and triangle ADSBDC are similar. I'll not write the reason why they are similar. All right. So
Sargav, your video is not visible.
ABC similar to triangle ABC. They're similar because this is 90 degree, this is 90 degree, this is these are vertically opposite angles, so they're similar. So if they are similar, since two angles of the two triangles are equal by AA similarity, the two triangles are similar. So by AA similarity. So by AA similarity, triangle ABC is similar to triangle ADSC. Now, if these two triangles are similar, the corresponding sides should be the same proportion. So I'll take AB by A dash B dash equal to CB by B dash C. B dash C. Then let's further simplify this so that we don't have to do it all, we don't have to go through it again in a later stage. So CB. Now look at CB. CB can be written as OC. OC minus OB dash. OB dash by then B. Yes, correct. Then B dash C. CB, right? So CB can be written as OB minus OC by B dash C. B dash C can be written as OC minus OB dash. Now let's bring in the values. So OB is minus U minus OC is minus 2F by OC is minus 2F minus OB dash is minus V. So now open the bracket, minus U plus 2F by minus 2F plus V. So AB by A dash B dash equal to minus U plus 2F by minus 2F plus V. Let's call this equation 1. Then again, these two triangles are similar. So triangle MNF similar to triangle A dash B dash F. So if they're similar, MN by FB dash equal to NF by sorry, this is not FB dash, MN by A dash B dash, then NF by FB dash. Now if you look at MN and AB are same. So instead of MN, I'm going to write AB by A dash B dash. I hope it is visible. Yes, A dash B dash. Then equal to NF by FB dash. Of course, we can change FB dash here, but let's not change it yet. So
Sir, not clear.
NF, let's look at NF. Now, when the aperture of the mirror becomes very small, N and O will coincide. So we'll use that property. All right? So when the aperture becomes very small and coincides with O. So if it coincides with O, therefore AB by A dash B dash will be equal to OF by FB dash. I'm going to continue here. So this implies AB by A dash B dash equal to OF. OF is the focal length, which is okay. Let's try OF again. Then FB dash can be written as OB dash minus OF equal to, so OF is minus F by OB dash. OB dash is minus V minus OF. OF is minus F. So this equal to AB by A dash B dash equal to, now minus F by minus V plus F. Let's solve this equation 2. So AB by A dash B dash equal to minus F by minus V plus F. Then let's look at equation 1 and 2. If you look at equation 1 and 2, the left hand sides are same. So the right hand side should also be same. So from equation 1 and 2, so here we have minus u plus 2f by minus 2f plus v equal to minus f by minus v plus f. Now all we have to do is cross multiply. So let's cross multiply and write it. Minus u plus 2f into minus v plus f equal to minus f into minus 2f plus v. So let's multiply. Minus u into minus v is uv minus uf minus 2vf plus 2f squared equal to, open this bracket, 2f squared minus vf. Cancel, cancel. Then bring everything to the left hand side, whatever remains on the right hand side. So uv minus uf minus 2vf plus vf equal to 0. So this is uv minus uf minus vf equal to 0. So far we have this. Now I'm going to further simplify this. So I'm going to divide all the terms by u, v, and f. Divide by u, v, f. So uv by uvf minus uf by uvf minus vf by uvf equal to 0. 0 divided by uvf is 0. So I'm going to cancel, 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 cancel. So what remains? 1 by f minus 1 by v minus 1 by u equal to 0. So this can be written as 1 by f equal to 1 by v plus 1 by u. So this is called mirror formula. That's a long, it's a hell of a derivation, right? So you can copy that, copy them down. So I'm starting from here, and then I'm coming, and then I'm going over there again. So copy this. So like I mentioned, I will try to upload this same video on YouTube so that you can watch it over and over.
Sir, we can't see now. How will we copy? It's not clear.
So Ayush, when you're done copying, you please tell me so that I can make sure that everyone else has finished copying. You need to understand what is being done here in the process, because only when you understand this, the image formation will be easy. Otherwise, the image formation will be very tough, and solving numerical problems will be very tough. Otherwise, numerical problems are also very easy. So this is called mirror formula. 1 by f equal to 1 by v plus 1 by u. Or you can write it 1 by v plus 1 by u equal to 1 by f. All right, I thought that I might not be able to finish it in the given time. It's good that we have finished well in time after shortening many of the steps. Some of you, when you're given an assignment without working on the previous questions that were solved, you try to solve the assignment. You need to learn. Like yesterday, I gave you an assignment, and the assignment, without even trying the 2 questions that I solved, without trying to understand those questions first, some of you tried to solve that given assignment. And you simply give up and say, I don't know. You need to practice and learn the ones that we solve first. Only when you learn, you attempt the assignment. That's like that. So I think right after me, Sir Chandru will be picking up the class. I'm just waiting. No assignments today, all right? What you can do is the previous physics assignment that I gave you, I want you to do it properly again. Those of you who did not submit. The diagrams that I asked you to draw, you draw them again properly, neat and tidy, keeping enough space for writing the description, because in the next class, we're going to talk about those diagrams. All right, then that will be all from my side for today. All right, just wait for the video to be uploaded on YouTube, so that if in case you missed out anything and you want to revise, you may watch on my YouTube channel. Okay, Sir Chandru, sir, you be ready. I'm ending my meeting here.